All right. Yeah, perfect. So driving cost efficiency for battery packs, certainly one of the defining questions in the battery industry at the moment. The question for us is, how do we catch up to China and how do we actually move ahead? So my name is Steffen Wirth. I'm associate partner at Porsche Consulting. This is my colleague Felix Wolff, manager of our battery team. So we have presented a 20 minutes, or prepared a 20 minutes presentation for you guys, and we will also have 5 minutes at the end for your Q&As. So let me start by really shortly showing you what Porsche Consulting does, what our battery team is, and how we interact with our clients. So first of all, we have direct access to the Volkswagen Group. Obviously, we're closely linked to all the brands, Audi, Volkswagen, Bugatti, and we are really closely linked to the battery cell producers like PowerCo and V4Smart as well. So that makes us unique in the market because we constantly evaluate market trends and we gain deep insights into the battery value chain to actually stay up to date on what is happening in the electric transformation. So on the other hand, and that's what you see on the right side, that might be new for you, our work reaches far beyond what Volkswagen Group actually is. So we partner with a lot of clients along the value chain, starting from raw materials, going over to cell production, cell integration, ramp-up topics, and lastly, obviously also recycling topics. All right, enough with marketing. Let's focus on BEV costs. Here we have the reality check. So on average, a battery electric vehicle at the moment is 28% more expensive than its counterpart with an internal combustion engine. Why is that? Well, it's the battery pack. The battery pack in the C segment accounts to about 11,000 euros. And the most expensive component within that is the battery cell, accounting for 61%. So let's break that down to regions and see how we actually compete with China. So Chinese OEMs currently enjoy a cost advantage of about 40% when compared to Europe. And there is a reason, and we summed that up on the right side. Firstly, is cost-intensive architecture. And when I talk about architectures, I'm talking about integration of the cell into the vehicle. So cell to module versus cell to pack. Second thing is certainly expensive cell chemistries, so NMC instead of LFP. Then, second reason for us is a lack of battery-first thinking. So that obviously results in overvariation of battery pack designs. We gotta admit, we are just a little bit too vehicle-centric. Tech is not first at the moment. Thirdly, we see a lack of prioritization in the market. So, I mean, we're not really focusing on certain key performance indicators. So by trying to improve safety, charging, range, all those performance indicators at the same time, we actually end up by not improving anything enough. Fourthly, we have strict adherence to requirements, actually focusing on 1% client niches. And we gotta admit, they don't really all contribute to a perceived customer benefit. We have to look at requirements. And lastly, it's certainly limited cost control. We are in Europe less vertically integrated and therefore have less transparency in the market. So if you add that up with regional drivers like cheaper labor costs, cheaper energy costs in China, you actually know why this gap exists. But the question is, how do we actually reduce this gap on the short term and the long term? So there's definitely good news for Europe's battery industry. Sustainable cost competitiveness is not a dream. It all comes down to, I would say, effective cost management, reducing material costs on the short term, and building up your battery strategy for your battery portfolio on the long term. So focusing on short-term actions first, we see a chance of addressing about 8% of the 40% cost gap at the moment. So by using detailed component analysis and also a cross-functional workshop with different departments, we can identify all the levers that are necessary to bring down your battery pack. And that's actually a legacy business at Porsche Consulting. So as we see, short-term measures are obviously the first thing to close the gap. Felix, over to you, giving us some insights on the short-term measures.
Yeah, cheers, Steffen. And to showcase why actually European OEM need to take care of the cost, we pulled together two actually packs that will hit the market end of the 20s roughly, with very similar performance parameters. So you see, they're both NMC, they're both high power, they're both round about 100 kilowatt hours. Nevertheless, the guy on the left is over 30% more expensive, and this is not because of performance, this is because of poor design. And once you decide and opted for concept, it's about how do you get this cost down after you can't really change your concept anymore, or you get just market delays. So what to do? You need to attack cost, and you need to attack cost obviously for the cell. In Europe, we're mostly dependent on the cell supplier, so take care of all the subsystems around. And there, it's about data crunching. Really get down into your CAD drawings, get down into your concepts, and go through component by component to try to discover levers that could end up, and that's not a made-up number, that's actually a project number, €9 per kilowatt hour, which, if you think about 100 kilowatt hours, is a massive saving in the battery alone. If you do that, don't do it only with engineering. It's kind of a common practice that controlling on the one side and engineering on the other, they meet. One says, hey, your part is too expensive. The other says, yes, but it is expensive because 1, 2, 3, 4, 5. What you need to do is get cross-functional people in, get your manufacturing guys in, get maybe procurement in, get HR, get external consultants, get marketing benchmarks whatsoever, and drive down cost. And talking about mechanical system, a prior project, we saved €2.60 nearly, only in the mechanical, and I want to showcase one single component, how we did it. And I opted for the foam of a cell-to-pack concept. Why the foam? I think it's a quite interesting bit. We had the colleague from Henkel a bit early on. He most likely agrees because it serves two functions. It serves a thermal function, trying to protect the cells from each other in case of thermal runaway. Also serves a mechanical function, trying on pack level get rigidity in, and on component level within the pack, preventing relative movements and absorbing shocks that might inflict damage on the electronics or the electrics. So complex part, really difficult to tune, but we pulled out 5 levers of how you can get the component or the cost allocated to the component a bit down. First one is the cream time, so the time the polymer takes after application to increase in volume. If you increase that, simply speaking, it makes things easier for manufacturing because they have more time. On the other hand, if you increase it too much, you might just end up with a lot of liquid at the bottom and no real foamed up pack. Can pull out over €1 per kilowatt hour per pack just from optimizing the cream time. Second one, straightforward, increase the foaming ratio. So the ratio between foam in final state and foam in initial state. If you go higher than 3 to 1, essentially you need less material in the pack in the beginning, and it becomes more over-curing. Third one is tricky, as it conflicts a bit with the cream time from lever 1 is curing. I think all of you that were related to pack design and pack assembly thought about what do we need to do with the foam once it starts curing. How long do we have to keep it somewhere? Do we need to heat it? How is it in winter? How is it in summer? So it really takes careful consideration and maybe even split up 2 components depending on the time of the year to optimize your curing efforts and drive down scrap. Lever number 1. Second, get rid of all the capex in manufacturing and assembly you don't need. Number 4 and 5, I would really go briefly through, is reducing pressure. So you always have an indefined state when you put in the foam. Foam increases in volume, and depending on your tolerances, you might have too much foam, too little foam, have basically an overflow valve or overflow orifice in the pack without making a mess. And lastly, EMC, always kind of interesting when you have polymers flowing around, but you need metal-to-metal contact. So apart from going really deep dive into polymers, let's talk big picture again. Steffen.
All right, thanks for that, Felix. So what is the plan for the long run, actually? So looking ahead, we think we can achieve about 19% of that cost advantage, depending on how ready we are to really rethink what we do. I would say standardization is the name of the game. So let's deep into that. How do different companies and different regions actually approach that?
What to do is easy sentence, hard to do, minimum complexity, maximum flexibility. And I think all of you know the Blade battery by BYD, and this is kind of a very good example of how they did it to get minimum complexity, but quite a lot of range within their portfolio. They use one chemistry, LFP. They use two different cells, short and long blade, and essentially the rest is similar integration. They put it either longitudinal or twisted by 90 degrees, and they can scale really well across reefs, across plug-in hybrids for some sorts, and of course BEV of different concepts. The second good example are the colleagues from Munich. They just presented at the IAA a couple of weeks ago, the Neue Klasse, with now started off with one chemistry, NMC, started off with two cell formats, so cylindrical 4695 and 46120, and really similar concept, really similar integration throughout all the new cars and also retrofit into the old batteries that will hit the market in the upcoming years. That's what the CTO actually claimed at the IAA. But I think, or we think, they missed a bit the LFP train when designing the concept. So they weren't too certain about how deeply will LFP penetrate the market. And if you talk cylindrical cells and LFP, it's not an ideal match. So what they had to do is second integration form, prismatic cells, LFP cells, and then trying to make it fit in the best way possible to the existing battery and vehicle portfolio. So target state. Steffen mentioned it in the beginning. There we go. Target state shouldn't be think vehicle first, but think use case first. Your customer wants a certain product. Your customer doesn't really want a certain battery or wants that very specific coupe in the shape you're trying to design it. He wants to have either a cheap car or a car that goes from A to B, or our legacy, of course, Porsche, something that goes well around the bump and the corners. And what we recommend is have a modular battery platform designed around those use cases and not have a vehicle platform first and then think what kind of batteries can I integrate. If you think use case first, you need to choose your technology. So as an example, for the entry segment, LFP I think is more or less the four-cylinder engine of BEV era. Nowadays that's a must. And for the rest, we're talking NMC, we're talking semi-solid and NMC in a high-performance tweak. Important here, there's no all-solid state chemistry here, because we do see some challenges in introducing that into big series, even though we see concepts turning up through the next years. After you chose, and you really firmly chose your technology, think about the cell format you want to go through. LFP means prismatic, more or less. The rest, you need to choose. Do you really want to go for prismatic? Issues with thermal propagation, maybe, but benefits on the energy density side, or do you maybe want to go for cylindrical like BMW did? And after you are sure that technology and cell format are fixed, try to keep everything constant. Everything around that should be one design, should be one type of integration, and be as modular as possible. Sounds good in theory. Question is how to do that. Let me give you 4 examples of what to do in terms of integration. It seems low in bill of material cost, but if you think portfolio-wide, it actually adds up to quite a big ticket, is polymers and fixing. So all screws, all rivets, nuts, bolts, whatsoever, get a catalog and get it not for one car, one assembly location, but throughout the portfolio, unified, standardized. Number 2, the polymers, thermal interface material. BYD, for example, is doing a really good job by using one thermal conductive adhesive throughout the portfolio. Can do the same. Number 2, cooling. When you think about cooling, there's basically 2 archetypes, either go between the cells or go top or bottom or both. Choose one. for the entire portfolio and stick to it. Don't come up with a performance derivative that then uses the other, or say, okay, for the cheap one, we use A, but for the high performance one, we need to use B. Number 3, cell connector. This is interesting when you talk about different cell formats. So you should think about how to unify the cell connector in the best possible manner. So cell terminals, for example, relative to the battery pack, should always point in the same direction, whether it's cylindrical or prismatic, either top or bottom, not both. Same goes for material and thickness of the material. Nowadays, I think aluminium is benchmark to use for cell connectors, but same thickness and same kind of geometry, same kind of topology of how you connect the cells. Really important. And then it goes onto electronics, so FPC connections and sensors. Try to use the same sensors, same positions, and similar logic to just increase efficiencies of scale. And lastly, big ticket item, e-box, high voltage, how some other OEMs call it. It's all about modularization in there. So try to get shunts, fuses constant across the entire portfolio. Looking at the use cases again, not to the vehicles. Try to get modular DC-DC chargers, modular inverters that go by steps and have a lot of carryover parts and are always at the same location in your battery pack. And if you'll actually do all that, what's the bottom line? Steffen?
All right, so what's the bottom line? Let's say closing the gap between Europe and China is not only possible, it is achievable, but we have to look at short-term measures on the one hand and long-term measures on the other hand to leverage the maximum potential. I would say time is crucial. Yeah? Our model estimations at the moment show that pack costs in China are dropping from 67 to 56 euros per kilowatt hour until 2030. Those numbers already include production innovations like LFP dry coating, obviously, but we have to be fast and we need to act fast to get the catching up done right now. So this actually brings us already to the end of our presentation. If you'd like to read more about us, check out our features in the academic papers that you see up there. You can also find us in different publications, the Handelsblatt, the Manager magazine. That's about it. I'm really happy to open the Q&A. I think we do have a couple of minutes left to answer your questions. Thank you very much.
Thank you so much, Steffen and Felix. Very insightful presentation. So I just open the floor for question. Any question from the audience? Yes, please.
You mentioned that about dry coating. Is there technologies around efficiency of production covered in this cost side of things?
I think dry coating obviously is for cell production one gigantic cost lever, but not all the levers are in terms of production. I think a lot is about design as well, smart design, feature integration of components.
So the actual efficiency in the production is not a big lever?
It is, but you need to think all levers, because if you just look at one, you're going to be lost and you're not going to be cost competitive.
Yeah. You go first, sir.
One question on the battery manufacturing process for European OEMs. So different OEMs have different strategies there, right? I mean, your own mothership, on the one hand, they buy the modules directly from CATL, from XPS, from LG as well. BMW is a bit unique. They're buying the cells, they're building their own modules. What do you think will happen in the future? Will more OEMs go towards cell production even? Or will there be a case that module production will come directly from Asian suppliers and European OEMs will only assemble the packs?
So I'll give you a very consulting answer, it depends. When we look at European OEMs, I think the cell industry faced enormous hardship over the last couple of years. The only one really standing is PowerCo, maybe ACC with some extent. So will more European OEMs go actually into cell production? I don't think so. When you think about integration into modules or pack, most likely it's going to shift more towards pack because cell to pack will gain traction, obviously. It will be a question of cash, and that sad to say this on the battery tech summit, but that will depend on how well do the internal combustion cars sell in the upcoming years. So how much cash can an OEM generate to then spend it onto assembly lines and spend it on design? So what we see currently is a shift to buy packs, where they basically design a spec sheet, give it out to either Korean or Chinese companies, most of the time Chinese companies, because they're just cheaper, and say, here, please do the best you can do, fulfill our performance. Difficult bit is, if you do that over long term, you obviously lose competence. And I think we as Europe, it's our task together to keep it rather in-house and to keep assembly of packs in Europe in the long term, yeah.
Okay, please. Thank you.
Hi.
Hey.
Just a strategical question is regarding what I understand. So to be modular in the battery, you need a kind of subsystem which is a standard, right?
Yeah.
So that's mean you drive the sub-supplier that to be deliver you every time the same parts in every, and this will be dangerous that we have it now from the history of combustions. So how is the question if you need something modular, your sub-supplier need to be also modular, because this will be more, in my opinion, for the sub-supplier and supplier, this diversity will be needed also in his product, that his, for example, thermal management, which is, I'm coming for that, that I deliver you the thermal management system for your battery. This is for me the same if I deliver to the other customer with small changes. And this is exactly what we needed in the future, because we are a little bit tired for this customized standard part for the battery for OEM 1, 2, 3. This will take a lot of invest money and will also make it a little bit tired. So that's why I'm 100% sure that modularity is the future, but it will be better that this modularity will be acceptable also for the sub-supplier, because in this case you will have a really very, very low-cost product which support you also in your final business, right? So this is my question, and also a little bit notice.
I think it's actually joint targets, because as a OEM, you want to have a cheap pack, right?
Exactly.
As a sub-supplier, you want to have cheap components. Everybody wants to earn some money along the value chain. I know for suppliers, the earning money bit right now is really tricky. Number two is technical solution. I think of the last 2 battery generations, we saw kind of opening diamond of different OEMs trying different solutions, because just they weren't sure, right? It is now the second, third generation of electric vehicles penetrating the market. We do see a trend for reunification again. So cooling between cells, for example, will spread through different OEMs, and that gives a chance to you as a sub-supplier, sub-supplier, to say, okay, our benchmarks as well, our different customers show, for example, 3 millimeter diameter of cooling channel is the best way to go for that use case of range. And that will give you a lever to unify what you sell to your customers as well, because they're not willing to pay more for individual solutions if you give a discount on the standardized one.
Okay. So just because the technology, production technology, what we have it now, so 3D printing, rapid prototyping, everything, allow us to be a modular in the future. And to be honest, we are looking for kind of communication between OEM level, I don't know which level, so to have, for example, for the thermal management especially, a kind of a platform in which we can play like a modular, not only for us, as also for our colleagues in the business. And this is what we see also is a good opportunity for you to have a very good cheap product. And so this is my intention, or my remark, what I have noticed.
So we're always happy to exchange. We need to take care of compliance though, right? So make sure that
because what we see that a lot of OEM, they think this is my supplier and he deliver what I need. And this is exactly what we want now in the future to limit it. So we want to be more in the corporation level, even if it is a third or fourth year. Sometimes modularity from his side will support you in your price very, very well. Yeah. So that's why this is exactly what we're saying. Yeah. Thank you very much.
Thank you so much.
You're welcome.
Thanks.
Any other question from the audience. Just probably the last question from me. So in the slide you compare like starting with the price actually bringing down. There was, I think, prismatic and the cylindrical cell. Would the geometry matter in applying the solution that you are recommending for reducing the cost, or?
You're talking about the different pack.
Yeah, with the same energy density, yeah.
I mean, yes, obviously the cell format does have an impact. In this very case, it is cylindrical actually being cheaper because the way they integrate the cell is way more straightforward, and the way the other competitor did it was kind of performance-based, very slim in terms of design, very high performance, good engineered, robust design, but less focusing on the overall cost. So that's why the prismatic was more expensive in that case. Yeah.
Great. Okay. Thank you so much for the great presentation.
Thank you.